finish off with pros and cons, repetition, and unique cases. So here it says car number plate, because it's in the action country, consists of a letter other than I or O. So that's what I'm going to do. First one consists of a letter other than I or O. So I'm going to go I, O, and I'm going to cross them off, which is a lot easier than writing the other 26 letter options below. Followed by 3 digits. Digits are numbers. 3 different digits. The first can't be 0, so I'm going to go 0 and cross it. The first can't be 0. And then it's followed by any 2 letters which are not repeated. So these 2 letters at the end are not repeated. They have nothing to do with the first 2, okay? On a diploma, this would have to be specified better if it's a diploma style question. It would have to say followed by any 2 letters which are not repeated. Just like, and written in a better way, just those 2 letters aren't repeated. So, because some people think, well, does that mean that this one can't be repeated as well? This letter has nothing to do with these 2, okay? It's just that these 2 can't repeat each other. So, if this one was B, this one couldn't be B. If this was A, this one couldn't be A. If this is A, it doesn't do anything to reflect on these 2, okay? It's the question that has to be written more precisely. All right. So, how many options, how many letters are there in the alphabet, first off? 26. Everyone's really good with vowels. A, E, I, O, U. There's no sometimes Y. Okay? There's 5 vowels. And then I ask consonants. People are like, they read it as consonants. No, consonants. Consonants are just not vowels. Okay? So consonants means not vowels. Forget that. So vowels is 5, so there's 21 consonants. Okay? A, E, I, O, U are your vowels. There's 21 consonants. So, this is the fact. So we can't be I or O. So remember, we list all our options below. I don't really want you to write all the options below. That's 24 letters. That would just suck. So we're not going to do that. So you can write your options below. And then above, you write the number of them. So how many options are there if it can't be I or O? So, 24. Because there's 26 letters, but it can't be 2 of them. Oh, that's not okay. Then it says 3 digits. Does it say that those digits can't be repeated? No, so we assume that they can. The only specification is this one can't be a 0. Okay? Because the first word cannot be a 0. So how many options do I have here? 9. So I have the numbers 1 to 9. And what about these 2? How many options do I have? Okay. Nope, it doesn't seem that they can't be repeated. 10. Because we have 0, 2, 9. 0, 10, 10. Then it says followed by 2 letters which are not repeated. So how many options do I have for the first one? I have A to Z. 26. Once I have there's no repetitions, I'm going to hold them there. So I'm going to hold A there, let's pretend. So then I have B to Z. Then I have 25. And your calculator, 24 times 9 times 10 times 10 times 26. 14,040,000. Whoa. So James wants to travel from Pitland to St. Luke's. Here's Pitland to P at St. Luke's. How many different routes are there from Pitland to St. Luke's? Now on this one, people will be like, I don't know how this fits in this unit whatsoever. You can use the fundamental counting principle to answer this, or you could literally just count pathways. And I've seen this on the 30 diplomas. I haven't seen it on 30-1 yet. It's on the ultra zone, but it can come if it's fundamental counting principle. However, you could just count them. You could go, okay, I have 1 pass here, and then 2, and then 3, and then 4, and then 5, and then 6, 7, 8, 9. You finish 9 passes, right? You use the fundamental counting principle because it's parts that make a whole, right? There's 2 pathways that I can take that can get me to through Q, and then there's these 2 pathways that can get me to X. So I need to go through, take this path and this path to get me to X, correct? How many options do I have for this part? 2. And then here, I have 3. I need to take this path and this path to get me there. So I multiply. So I have 6 paths along the top. Okay. And this one I have 3 paths. 1 path. I take this path and this path, so that gives me 3 paths. Now, the question is, do I add or multiply these? Do I take these top paths and these paths to get me there? Or do I take these paths or these paths to get me there? And or. Yeah. Or. It's not going to be and. Because if you're answering and, you're saying I need all these paths and all these paths to get me there. That means you're driving every single path to get you there. You're not going to do that. That's just silly. You're going to take either some of these paths, or you're going to take one of these paths, right? These paths, or. So you add them. You put it there. And it's or. So that's 9 times 4. Whenever you use the word or, it's and. Whenever you use the word and, it's multiplier. Number 8, the telephone numbers allocated to subscribers in the rural area consists of one of the following. The digits 3, 4, 5, followed by any 3 for the digits, or, the digit 2, followed by one of the digits 1 to 5, followed by any 3 for the digits. So we have or in there. So we have 2 cases. Whenever we have cases, we add them, right? Okay. Says how many different telephone numbers are possible. So the first one is the digits 3, 4, 5. So the digits 3, 4, 5. So I have the options. The first one has to be a 3, 4, and then 5. So those are the first 2 digits of the number. Followed by any 3 further digits. So what are my options here? 0 to 9, 0 to 9, 0 to 9. It doesn't say you can't repeat series, you can. Then or, so plus, the digit 2, remember I list my options below, right? Digit 2, followed by one of the digits 1 to 5, followed by any 3 from the digits. On the top, we list all of our options, right? How many options we have. The number 3, we have 1 option. The number 4, 1 option. Number 5, 1 option. 0 to 9, 10 options. 0 to 9, 10 options. 0 to 9, 10 options. What do I do with all those numbers? Multiply, add, 5, 3, multiply. Because in order to get this actual telephone number, I need this number and 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 this number. I need all of them, right? I need all of those numbers, and I'm going to multiply. Or I could have this telephone number, which I need this number and so I multiply. That's why the fundamental counting principle is multiplication. I don't even, like, I'm circling and it is making straight up and down lines. So I have 1 option, I have a 2. 1 to 5, 1, 2, 3, 4, 5, 5 options. 0 to 9 is 10 options. I think that kindergarten handwriting is better than first. So it's multiplying 1 times 1 times 1 times 10 times 10 times 10 is 1,000. Plus 5 times 10 times 10 times 10 is 5,000. We have 6,000 options. When you're done with them even cases already, flip over. Okay, now we get into words. Words are all permutations, by the way. We haven't really went into full out what's permutation, what's a combination, but words are always permutations because the order matters. If you say order doesn't matter on a word, then the word even could be spelled any way with those 4 letters and it would mean the word even. Is that true? No. Even has to be spelled E-V-E-N. I can't go V-E-E-N and that's even, right? So words are always permutations because permutations order matters. And the order in which you write a word makes the word be what it is, right? So, consider the number of distinguishable 4-letter arrangements, and this is the thing that you have to read really, really closely, because sometimes we're rearranging the entire word English, or sometimes we're only making a 4-letter word out of all those letters. Okay? Just read closely. Consider the number of distinguishable 4-letter arrangements. So we're only making 4-letter words here. I know English has more letters than that, but we're only using 4. That can be formed from the word English. Now this is the catch. When given a word, this assumes you only have the letters contained in that word, the amount of times it occurs in that word. So I have 1 E, 1 N, 1 G, 1 L, 1 I, 1 S, 1 H. They do not have to say it doesn't repeat because it's whatever letters are in front of you. Okay? You have English. That means you have 1 N, 1 E, 1 G, 1 L, 1 I, 1 S, 1 H. You can't repeat them because you only have one of each. If you had the word even, you have 2 E's, a V, and an N. Okay? So it's whatever you have. They don't have to say it doesn't repeat. It's whatever you have in front of you. Determine the number of distinguishable 4-letter arrangements that can be formed when any letter can be in any position. So there's no restrictions. When there's no restrictions, you can do it in any order. When you have restrictions, you have to do the restrictions first. Remember I said that yesterday. So we have a 4-letter word. When I always get a word, I always check to see if there's double ups. If there's double ups, it's going to make a difference, or triple ups. So like English has 1 E, 1 N, 1 G, 1 L, 1 I, 1 S, 1 H. It will make a difference if there's 2 E's, or 2 L's, or 2 S's, okay? So always check if there's double ups. This one there isn't, so that's good. We have 4 letters in any position. So for the first letter, and after a while, you're not going to have to write this up, it's painful. For this first blank, I have the option of E, N, G, L, I, S, H. How many letter options do I have? 7. Because it's a word, which means I can't repeat, I just can have whatever I have. I have to pick a letter and keep it there. Just gotta keep the H there. For the next blank, I would have E, N, G, L, I, S. So I have 6 options. And say I keep E here. Then I have N, G, L, I, S. I have 5 options. Say I keep the L. And I have N, G, I, S. Which is the 1. And I multiply them. What? 7 times 6 is 5 times 4. So I have 840 different words, 4-letter words that I can make if I have no restrictions. Okay? From the word English. So what if the first letter must be an E? First letter has to be an E. I have to get my restriction first. My restriction is the first letter has to be an E. So my only option I have is E. That's one option. How many other options do I have for the next blank then? N, G, L, I, S, H, like 6. say I keep H here, then I have 5, then I would have 4. 6 times 1 times 6 times 5 times 4 is 720. Okay. So the moment I restrict it, oh, I'm throwing my marker. I'm control. Alright. So 1654, the moment I restrict that first letter to be an E, I drop the amount of words I can make, right? Which makes sense. If all of a sudden you restrict the first one to be an E and you're getting more than the no restriction one, there should be anything that you did as well. Okay? Now, C. The first and last letters must be vowels. Some people say, well, I have the vowels A, E, I, O, U. I have 5 options. No, you don't. You have the word English. You have E, N, G, L, I, S, H. That is your option. Okay? So what vowels do you have? Michael, what vowels do you have? E and I. That is all we have. You don't have A, you don't have O, you don't have U. You have the word English. Okay? So the first and last letters must be vowels. Okay? So I'm going to start with the first. If we start at the back, it doesn't really matter. One or the other. I'm going to say this one. So for this blank, I would have the option E or I. Correct? So how many options is that? 2. Now people will tell me I have 2 for the back one as well. No. You could have started with the back first and then E and I. But you're going to leave one of them somewhere. Right? So at this point, I'm going to leave the I here. So for my back one, I actually only have E left. So I have 1 option. You don't have 2 and 2. You have to leave a letter somewhere. If you say you have 2 and 2, that would mean that your first letter could be an E and your last letter could be an E. Is that possible? You have 2 E's options? No. Okay. Now I have no restrictions on the middle ones. So I can have an N, a G, an L, an S, or an H. Because I use up the E and the I. Not because these have to be consonants. They just have to be consonants because I only have 2 vowels. So 5. And then say I keep the N there. I have the G, the L, the S, the H, so I have 1. 2 times 5 times 4 times 1 is what case? So now with just restricting my first and my last 3 vowels, I've knocked the options of 4-letter words down to 40. I still would not suggest that you try and list all the cases, which some people do. They think that they can just list up 840 is crazy, but 40 you still gonna probably miss 1 or 2 of the options, right? This one is a trick. It's not hard, but you have to maybe start. This is one that people forget about. The word must contain a G. Must contain a G. Doesn't specify where that G needs to be. Now it needs to contain a G. So what people do is they go, okay, I'm going to put the G first. I have 1 option. There's 7 letters. I've used up 1, so then I have 6. I have 5. I have 4. The word contains a G. I have my answer, and I'm done. It contains a G, but that's not the only 4-letter word option I have where it contains a G. Where else can the G be? In the second place, or the third place, or the fourth place. You actually have 4 cases. You have a case where it's the first letter. You have a case where it's the second letter. You have a case where it's the third letter. You have a case where it's the fourth letter. Does it change the outcome if I'm making it in the second spot, the third spot, or the fourth spot? No. So what I could do is I could go, okay, 1, 6, 5, 4, 1, 6, 5, 4, 1, 6, 5, 4. And then what I do, I go this plus this plus this plus this because cases you go down on. Or what could I have done? Okay. 1, 5, 5. So I could just do it once, like this, and then multiply that by 4, because I have 4 blanks for that sheet, right? 6 times 5 times 4, we said 120. 120 times 4, 40. answer will be on the diploma, 120. Scary part is most people pick that 480. So just remember when it says must contain edgy. It could be here, okay, everyone just forgets that. Then I remind them, they're like, oh, right. Okay? So here's the questions to try, because I just went through a whole bunch of types with you. I want you to try them. If you look at the next page, actually, page after that, it has the answers. Okay? So when you're working on them, you're going to do 1 to 8. You're going to check your answers. If you don't get it right, answer your answer. You can ask me and I can help you. Okay? So you're going to have the next few minutes to work on that. Not a ton of time, so get work on. So I think the factorial notation, that's that little exclamation mark, and I told you that it's from whatever that number is, so it's 7 factorial, it would be 7 and decreasing by 1 all the way to 1, right? So 7 times 6 times 5 times 4 times 3 times 2 times 1. Until we hit 1, right? That's what it starts. So if I give you n factorial instead of a number, I give you n factorial, it would be n times n minus 1, 1 less, and it would be n minus 2 because that's 1 less. And then n minus 3, 1 less, n minus 4, n minus 5, n minus 6, and so forever, right? Unless I told you what n actually was, then you could stop once you hit 1. So if n was 7, then I'd be 7, 6, 5, 4, 3, 2, 1, right? So whenever you have n factorial, you can just represent it by going down by 1, which will make sense. So we start with simplifying, and then we'll do solving, which is more so what you can see on your homework. Simplify the following expression. Use the answer in product form where appropriate. That means don't expand it out to like cubes and stuff. So, what I always say is you want to expand the one that is bigger. So, say that, let's do something for simplicity sake that's not n. So, say I have 7 factorial over 5 factorial. Okay? Which one is bigger? Well, 7. It's 7 times 6 times 5 times 4 times 3 times 2 times 1. Correct? So I'm going to expand the bigger one until I get it to look like the smaller one. So for this example, it would be, that's really nice, 7 times 6, 5. And instead of writing 5 times 4 times 3 times 2 times 1, what could I write? 5 factorial, could I not? So I can write 7 times 6 times 5 factorial. Could I not? I know it looks silly, but I could do that. Could I not? Because 5 times 4 times 3 times 2 times 1 is 5 factorial. Why would I do that? Because look, I have 5 factorial on the bottom. Now what can I do with them? Cross them off, and my answer is 42. I'm going to throw this marker away. I love it. Does that make sense with numbers? So we're going to do the same thing, but with letters. So, what is bigger? N plus 2 factorial or n factorial? N plus 2 is actually bigger. Because how do I expand n plus 2? N plus 2, what's 1 less than n plus 2? N plus 1, what's 1 less than n plus 1? N, what's 1 less than n? N minus 1, what's 1 less than n minus 2, right? So, n plus 2 is bigger than n because I can expand it out and it'll have an n factorial in it. So let's see that. N plus 2 factorial is just n plus 2 times 1 less. So n plus 1 times 1 less, n times 1 less, n minus 1 times 1, n minus 2, right? So instead of consistently writing that out, like instead of writing 5 times 4 times 3 times 2 times 1, I could write 5 factorial so I can cancel them off, right? So here I have n plus 2, n plus 1, and I'm just going to write n factorial, because it would keep going, right? And n minus 1, n minus 2, n minus 3, that stuff, right? And then n factorial is on the bottom, and they cancel, and I'm left with n plus 2, n plus 1. So you're really just expanding out the bigger one so it looks like the smaller one, so you can cancel them off. So the next one, n minus 2 factorial, n minus 1 factorial. Which one's bigger? If I take n minus 2 and I subtract 1 from it, it's n minus 2, n minus 3, n minus 4, n minus 5, correct? If I take n minus 1 and subtract 1 from it, what is it? N minus 1, n minus 2, n minus 2. So which one's bigger? N minus 1 or n minus 2? N minus 1, because when I expand it, it contains n minus 2. So I'm going to leave the n minus 2 the way it is. Factorial. The factorial symbol just means it keeps going on forever, subtracting 1. And on the bottom, I'm going to have n minus 1. 1 less than that is n minus 2. And then we put the factorial after that. And you just keep going. The n minus 2 factorials cancel, and everyone tells me the answer is n minus 1. The answer is not n minus 1. When the n minus 2's cancel, what am I left with on the top? When the n minus 2 crosses off, what am I left with on the top? A 1. Because essentially, actually, when you cross off two things like this, they cross off, they actually make a 1. I don't know if you might not have seen this before, but when you cross them off, I would make them turn into a 1. That is a 1. So I have a 1 left up here. If I just write n minus 1, n minus 1 is not the same as 1 over n minus 1. If you said n minus 1 is the same as 1 over n minus 1, then you're telling me that 4 is the same as a quarter. Is that true? No, I would rather have $4 than a quarter of a dollar. Okay? They're not the same. So n minus 1 is not the same as 1 over n minus 1. You have to remember that 1 on top if they cancel. What if they cancel off the bottom? Do you have to keep a 1 on the bottom? No. Any number can be written over 1. Like 4, you can write as 4 over 1. Why would you ever do that? If you were adding fractions. So you had a quarter plus 4. You write as 4 over 1 to do common denominators. So you got, right? That's the only time you really write anything over 1. So we have 1 over n minus 1. Okay. C. We have n factorial over n minus 1. The only one I can expand is n factorial. The other one is n minus 1. These are the same. So it's a little different than the one previous. So I'm going to expand n factorial in hopes that something matches. N factorial is n times, what's 1 less than n? N minus 1. What's 1 less than that? N minus 2. And then I use the factorial symbol. Because I can see now that the n's and the n minus 1 are going to cancel. If I'm actually left with n minus n minus 2, oops, not left with n minus 2 factorial over 1. Like I said, do I have to keep the 1 if it's in the denominator? So I could just n minus 2 factorial. Now, often they would ask us to just do something simple like that where we cancel, but we need to know that part in order to solve the equation, which is example 2, which is what we will see. You won't really see that part, you'll see the bottom part. So, algebraically solve this equation. So we need to deal with this part in hopes to get it to reduce so that the factorial symbols go away, because that makes life better, and then we can solve for n. So, which is bigger, n factorial or n minus 2 factorial? N, right? Because n can be made into n minus 2. So that's what I'm going to expand. So n factorial is n, 1 less, n minus 1, 1 less, n minus 2, and now I match the bottom. Equals 42. Now I have these that are the same. Because I just have a 1 on the bottom, I don't have to write it. So I'm left with n times n minus 1 equals 42. Now I have to expand because I don't know. So I expand, I distribute my n in. And you get n squared minus n. Now this has been drilled into your brain last year over and over and over and over again. If I have an n squared, or let's say it's an n, if I have an x squared, what do I have to do in order to solve anything with an x squared? Move everything to, should be stuck in your head still. Move everything to one side and set it equal to 0. If you have just like, say you had something like this, n plus 2 equals 6. I could subtract my 2, and I have n equals 4. I can just solve for n. But the moment you have a squared, and this year you're going to have a cubed or a fourth or a fifth degree, because we're going to be dealing with polynomials this year. The instant you don't have a degree 1, you have to move everything to one side, set it equal to 0, and solve every single time. Okay? So I need to move that 42 over. So n squared minus n minus 42 equals 0. How do I solve this? Grade 11, bring it back. You have to factor. So you have to factor this, you can't factor it, quadratic formula, I have to factor it. So I say to myself, so what times what equals 1 times negative 42? Negative 42. What plus what equals the middle term? Negative 1. So what multiplies to give me negative 4 and adds to give me negative 1? Yeah. Negative 7 and 6. And it needs to be negative 7 or you wouldn't get negative 1. So I can always check it. Negative 7 times 6, negative 42. Negative 7 plus 6, negative 1. So I know I'm right. Do I have to decomp? Do I have to replace this in middle terms, group them, and do all that work? No. You don't have to do decomp because I have a positive 1 in front. If this is a negative 1 or a number other than 1, you have to do decomp. Which means you replace this term with negative 7n plus 6n, group and solve. But because I have this positive 1 in front, I can go right to brackets and go n minus 7 and plus 6 equals 0. And then I solve them out. So I get n minus 7 equals 0, n plus 6 equals 0. And if anyone had me last year, I drilled this into your head that you were never getting away from quadratics. And that they're an underlining thing in most of 30-1. So if you're someone who's like, I just didn't get quadratics last year, you need to get quadratics. You need to understand how to solve. Okay? They are going to come back in most of the units. You have to know how to factor. You have to know how to solve by factor on a quadratic. It's in trig. It's in this. It's in polynomial. It's in transformation. It's in everything. So, move the 7 over by adding it, you get n equals 7. Move the 6 over by subtracting it, you get n equals negative 6. The catch on this one is you have to remember to check them. So, at this point, there's no more volume. So, if you take this 7 and you plug the 7 in here, we get 7 factorial over 5 factorial, correct? Makes sense. Negative 6. Negative 6 factorial. You can't have a negative anything factorial. A factorial symbol says you take from whatever that number is until 1, right? So 3 factorial would be 3 times 2 times 1. Negative 6 factorial, how would you ever get to 1? You're already below it, okay? You can't have negative factorial. So that is not the answer, and the answer is 7. And you could try it out. You could go 7 factorial divided by 5 factorial is 42. And also prove it to you. Great. All right. So why do we even try to do weird things like that? Because the permutation formula is n factorial over n minus r factorial. This is your formula sheet. I'll be giving you one exactly like this. You will have it for every test. If you're like, hey, is that on the formula sheet? If it's on the formula sheet, yes. If it's not on this formula sheet, no. This is the formula sheet. This is the one you get. It's exactly like this. You use it all year long, and you'll have a copy of it on your copy. You'll have a copy of it, and then you'll know exactly where the formulas are. You won't have to guess, because that's the exact formula sheet on your diploma. formula is on there. Bottom left, this whole like bottom left right here, for negations, combinations, binomials, not this unit. And what's nice about their formulas is they actually follow under headings, because that is the actual. So, using the formula, let's fill it in. It's NPR equals N factorial, N minus R factorial. You fill it in like this. So if it's 8P3, that's going to be 8 is going to be N, and R is going to be 3. It's NPR. So 8P3, N equals 8, R equals 3, and we fill it into our formula. So 8P3 equals N factorial, N is 8 factorial, over 8 minus 3 factorial. So it's going to be 8 factorial over 5 factorial. Punch in your calculator, or you can do 8 times 7 times 6. Why can you do 8 times 7 times 6? So if you write the top of 8 times 7 times 6 times 5 factorial, and 5 factorial. Right? Or you can just go 8 factorial divided by 5 factorial and calculate. So 336. There's also NPR button in your calculator. And it's a good thing to have, but it doesn't always help. So, NPR. So we're going to go 8P3. How do you punch in your calculator? You're going to go 8. So press the 8 button. Try it on your calculator, press 8. Then press math, left arrow, just like the place, or the same place you have for factorial. 8. Then math, then left arrow, and you're going to pick number 2. Number 2 says NPR. Then you hit enter. And then you put 3. Enter. And what does it give you? So you do 336. Okay. So it's 8, math, the left, number 2, and now, some people say, well, why the heck would I ever use that formula if I don't apply it? Which I would have said, I think I did in high school. Because you're going to get something like this. N minus 1 P2 equals 90. There's no N minus 1 in your calculator. You can't go X minus 1. For all of you who want to do that, you're going to go X minus 1, number 2, button 2. That doesn't work. X is always saved in whatever the heck last we found X to be. So you know that X is in your calculator. It's different for every single person. You can't go X minus 1 P2. You have to use the formula. So remember the formula is N P R equals N factorial over N minus R factorial. Right? So this is in the N spot. This is in the R spot. So we're going to fill it into our formula. So we're going to get N minus 1 P2 equals N factorial, N is N minus 1, so N minus 1 factorial, over N minus R, so N minus 1 minus 2 factorial. Technically we have N minus 1 P2 equals N minus 1 factorial over N minus 3 factorial. Now how even worse than it did before. The N minus 1 P2, what does that equal? Is there anywhere in there that gives us something nicer than N minus 1 P2? In the question, where does it say N minus 1 P2 equals? What is N minus 1 P2 equal? 90. So instead of writing this, I'm going to write 90. So we have 90 equals, now let's just make the questions we were doing. So we have n minus 1 factorial over n minus 3 factorial equals 90. You try and solve it. So now what I find people do at this point is they try and factor this. Remember, the only way you can solve for quadratic is move everything to one side instead of equal to 0. That will be something like everything to one side is equal to 0. Everything to one side is equal to 0. Everything to one side is equal to 0. You cannot solve for any of these variables until it is equal to 0. Why? Look at this, guys. They even give you a hint up here. So both 3x and 3x. This needs to be in the form ax squared plus bx plus c equals 0. And you can't find any roots. You can tell me up here. That's the form it has to be in. That makes a lot of sense. So move your 90 over by subtracting it, and you get n squared minus 3n minus 88 equals 0. You get negative 11 plus 8. So n minus 11, n plus 8. If you're someone who still can't factor, you need to learn how. You need to be my best friend for the next little while, because you need to know how to factor. You have to factor trig equation, so you need to know how to factor. So we're going to get n equals 11, and n equals negative 8 when we solve that. Negative doesn't make sense for an answer as well. You can try it out. Go 11 minus 1, so that's going to be 10. That's 10p2. 10p2 in your calculator should be 90. If it's not, you solved it wrong. Okay? And this are the questions for you to try are after this. So your homework is the other questions to try and these questions to try, and I'll check tomorrow and see if they're done. After this is the answers to the answers following that. So that's your homework. Nothing I do about it. Oh, lovely. Make sure you're looking.
You know, Armitage said, I wonder where did Jenkins go? I said, I don't know. Hey, it's during scheduled help. And then he said, I wonder where Joe went. I said, don't follow Jenkins. And he's like, her passion? I'm like, don't follow him either. I'm like, maybe follow the new guy. I don't know him, but do not follow the other two. It's not the smartness that I'm talking. It's the dynamic. You have to do the questions to try. So the one to whatever. So both sections of questions to try are due. So this is 1 to, I don't know. So you would have 1, 2, and 3. So those are your 2 homeworks. So 1 to 8 for the first one and 1 to 3 for the last one. And I will be checking tomorrow. Yeah. Oh, this is still done.